part of our ongoing discussion about severe local storms, we're talking about lightning, in particular lightning inside thunderstorms. Now, there are different types of lightning. There's cloud-to-air lightning, there's cloud-to-cloud lightning, and then there's cloud-to-ground lightning. Now, we often will see intercloud lightning, which is going from storm cell to storm cell. We'll see intra-cloud lightning, which is all within the same storm, the parent cell itself. This is a line of thunderstorms that was heading towards me very recently, but just putting on a tremendous light show at night where it's mostly illuminating inside the storm. So that's a lot of intra-cloud lightning. But the real threat to human life and property is going to be when you get cloud to ground lightning, which wasn't very visible at this moment, but as the storm approached, then there was an ongoing threat for that to be the case. So as we talk about lightning, let's cover some quick facts. What is it? Lightning is an electrical discharge. That's it. It's the exact same thing as if you walk across the carpeted floor in your socks and you go over and you touch the metal handle on a door and you see that little blue spark that shocks. Or you touch your unsuspecting roommate, housemate, or friend or family right on the earlobe and you shock them, right? That little blue bolt of lightning. That's all it is. It's lightning. Same thing. It's an electrical discharge, which means that it requires you to have a separation of positive and negative charges, right? If you've ever tested a 9-volt battery, the little rectangle battery, it's got the little posts on it. What's an easy test? To put it on your tongue and you feel the little tingle, the zap, right? You've completed the circuit, right? If you look at a battery, it doesn't matter if it's a AA, AAA, CD, whatever. On one end, it's going to have a little plus on the other, and it's going to have a negative sign, right? All circuits require a general flow of electrical current in order for it to complete the circuit. So when you put in a battery, you've got the orientation correct between the positive and the negative charges that allows for the electrical current to flow. Lightning is the same thing. You build up positive and negative charges inside the thunderstorm and in the surface of the earth, and then once those opposite charges connect, that's the electrical current, that's the lightning bolt. It's electrical discharge. Now, they're very thin and very tall, about 5 kilometers in length, sometimes only 2 to 3 centimeters in diameter. So you're only talking about something about the width of a pencil. That's the lightning channel. Now, it is true, lightning can leap out several kilometers away from a thunderstorm, in some cases even up to 20 kilometers. So yes, lightning can be very lengthy, but it's very, very narrow in diameter. One of the coolest things to remember, lightning itself, the temperature inside the lightning channel is about 30,000 degrees Celsius. This is 5 times greater than the temperature of the sun. Let me put this into perspective. The average temperature of the atmosphere, let's just go with it at 30 degrees Celsius. When you instantaneously go from 30 degrees Celsius to 30,000 degrees Celsius, that's a very rapid temperature increase. And what have we learned in previous lessons, right? When you increase the temperature of something, it expands. So when you increase the temperature of air, it's going to expand. Now, lightning happens very quickly. So in just a few seconds, it rapidly expands and then the lightning's done, so it cools back. So you have this rapid expansion and contraction that creates the sonic boom. That rapid expansion and contraction of the column of air due to the superheating inside the lightning channel, that creates the thunder that you're hearing because of this sonic boom from the heated channel of lightning. Lightning remains a very deadly weather event in our country, killing at least 80 people per year. It is, you know, even as a meteorologist chasing and observing storms, I mean, I'm not fearful that much of tornadoes. I am fearful of lightning. Highly unpredictable and can do an enormous amount of damage. As a discharge of lightning, or lightning as a discharge of electrical energy, let's cover the 3 main types of lightning. Intercloud lightning, intra-cloud lightning, and then cloud-to-ground lightning. Now, there are some other facets of lightning. We could do an entire semester, entire course on the electrification of thunderstorms, but for the scope and purpose of this class, I want you to focus on these 3 types of lightning. You saw them in the video. Intercloud lightning is going between cells within the same storm system. Then you have within the same cloud, it's just called intra-cloud lightning, and then the very deadly one is the cloud-to-ground lightning. We often just nickname it CG. So if you've ever watched some of my storm footage or you're just watching footage from storm chasers and they say CG, CG, it's because of the cloud to ground. This is the one that's going to strike you, which is why we're going to talk about it right now. Okay, air is a very good insulator, right? If you've ever gotten a cup of hot coffee from Starbucks or some other coffee shop, it's a paper cup and they give you the Java jacket, right? It's the little piece of cardboard that goes around. What's the difference between burning your hands touching the cup and you put that little jacket on there? If you look at the little jacket, it's got a little zigzag of cardboard. It creates a layer of air between your fingers and the hot cup of coffee. Basic thermodynamics and heat energy, right? Heat energy is always going to flow from something that's hot to something that's cooler. That's the only direction it goes. It doesn't go in both directions. So it would go from the hot coffee cup to your fingers. You're at 98 degrees. Coffee is usually served at about 140, 150 degrees. So there's the temperature difference. Air is the insulation factor there. So air is a very good insulator, so it makes it very challenging for lightning to happen even in the first place. So to have lightning, you need to have very strong charge centers very close together, right? We're talking about the separation between positive and negative charges. And we need to have very large differences in the charge strength. So you need a large accumulation of the positive charges right next to a large accumulation of the negative charges in order for the steps to happen for a lightning to occur. In order for lightning and a thunderstorm, you need to separate those large amounts. So how is this even done? Well, there's a lot of vertical motions going on inside of a thunderstorm with the updraft and the downdraft. And then you've got ice and you've got water. That naturally will separate out the charges themselves. This is the basic diagram of a thunderstorm. So in your notes, draw the little cloud right here and the surface of the earth. And here's what I want you to focus on. The very top half of the thunderstorm is positively charged. The bottom half of the thunderstorm is mostly negatively charged. Now, sometimes there is a very thin layer of positive charges right there at the bottom of the thunderstorm, but we're gonna negate that right now. We're going to look past it. We're going to focus. The bottom half is negatively charged. The top half is positively charged. Now, yes, this is how you get the inter and intra-cloud lightning because of these accumulation of charges. But we're going to focus here on the surface of the earth. If you've ever heard that the earth is grounded, right, or you talk about something grounded, whether it's from your car or from even your house, it's referring to the fact that the earth is negatively charged in general. That doesn't mean that the earth is entirely 100% negatively charged. It just means in general it is, right? If you've ever connected your car battery, you've had to jump a car before you, right? You connect the jumper cables from one car to the next. You have to very carefully connect the negative, negative, positive, positive, right? Okay, so the negative is referring to the grounding that's on there. You do not want to be the ground when you're trying to jump a car. It's just an example. It's just simple battery and circuits. It's all it is. Same kind of thing in our thunderstorm. So in the surface of the earth, there are actual free-moving, free-roaming positive charges. Those positive charges will accumulate in the surface of the earth directly underneath the thunderstorm. Why? Because of the strong accumulation of negative charges. The strong accumulation of negative charges acts as a magnet. It will attract all of those positive charges underneath this thunderstorm. Now, you have at the surface of the earth buildings and trees and other objects, which means that's going to be the focal point. These positive charges are going to start to travel up anything that's connected to the surface of the earth and go up into the air trying to get towards that accumulation of negative charges. And indeed, that's kind of the first couple steps for lightning to generate. The very first thing we'll talk about is this thing called a step leader. A step leader is a flow of negative charges coming out the base of a thunderstorm. This is ultimately what's going to create the lightning channel. So these will surge down to the ground in steps, and they can move in 50 to 100 meters. It moves fast, it moves quickly. It is surging down towards the ground. Here's a picture that somebody caught a long time ago photographing lightning. Here is the main lightning channel, and it actually illuminated before the step leader. They're stepping down really quick. This is in one, look how fast that is. It's just happening really, really quickly, something very fast, which is why you can't see it with the human eye. It takes advanced photography to even get close to capturing a photo of a step leader. At the same time that you've got a step leader surging down from the cloud, then we have to worry about the flow of positive charges coming from whatever's connected to the surface of the earth, which we call streamers. While the step leader is coming down, streamers are surging upward towards the cloud. Streamers will come from anything connected to the ground, trees, antennas, tall towers, flagpoles, telephone poles, blades of grass, people, all comes from these streamers, which is just a flow of positive charges going from the ground up towards the cloud. This is why lightning rods work. Lightning rods are necessarily to attract lightning. If the building that the lightning rod is on is going to be launching off streamers left and right, there's a lot of streamers will get ejected off of the top of a building. The goal of a lightning rod is to focus the energy coming from a lightning strike away from all the electronics and electrical circuits in the building. There's a direct pathway from the lightning rod with a metal wire straight down to the ground, so it diverts it away from the rest of the building. Lightning rods are meant to eject streamers first before any other part of the building, so that the streamer will go up and hopefully connect with a step leader coming down. This is an example. Picture of a lightning channel striking a tree. Here is an example of a streamer getting ejected off the tree. A single tree is not going to eject just a single streamer. It's going to eject multiple streamers coming off of it. So this is an example of flow of positive charges coming from the earth going upward while there's a step leader coming down. And if they just connect, there is our lightning channel that gets created. Now, once the streamer and the step leader connects, the next thing we see is what we call the return stroke. The return stroke, this is the visible stage of lightning. This is what you see. It's illuminated. It's just the lightning channel has illuminated until the channel itself can break down, and then it's done. Sometimes you might see second, third, fourth return strokes. It's where it almost seems like the lightning just kind of flashes and pulsates in a position there. This is just the basics of lightning. Bottom half of the thunderstorm is negatively charged. The upper half is positively charged. While the earth has negative charges, and we typically refer to it as being grounded, there is an accumulation of positive charges that occurs directly underneath the thunderstorm. Why is it there? Because the thunderstorm is so negatively charged in the lower half, it just acts as a magnet. It draws positive charges to accumulate right there underneath the thunderstorm. All right, we've already covered the fact that thunderstorm is nothing more than an extreme heating channel of air that can create thunder, right? Lightning's hot, 30,000 degrees Celsius. The air expands because it's heated, and that rapid expansion of air and then a rapid contraction creates that sonic boom that emits out the sound. So how far does thunder travel? Well, we've got a good metric for that. Between when you see the flash of lightning and when you hear the thunder, light travels faster than sound, okay? So when you see the light from the lightning strike and then you hear the thunder, count the time. 5 seconds per mile. So if you see the flash and then you hear the thunder 15 seconds later, 15 seconds divided by 5, we're at 3 miles away. It's a very simple calculation. Also a very easy exam question for me to include. You just divide by 5. So if you see the flash and you hear the thunder 20 seconds later, you're 4 miles away. The closer you are to the lightning strike, it sounds more like a boom. The further away, it's more like a rumbling. If you hear a cracking sound, you're really close, right? Because sound has higher frequencies and lower frequencies. The lower frequencies are larger wavelengths of sound, which is more like the booms, the bass, right? That can travel great distances. So if you hear the cracking, that's a high frequency sound, which means you're really close to where the lightning struck. All right, friends, that was just a real quick recap of what lightning is and the structure of a thunderstorm with the positive and negative charges that ultimately lead to the different types of lightning.